In this video, we are going to discuss the scenario of the non-parametric test with Wilcoxon sign and test. Non-parametric tests are used when we do not assume any assumption about distribution of data, whether it is normal distribution, binomial distribution, or any other kind of distribution. So it is usually applicable in the skewed data and the ordinal data and the nominal data also. In our scenario, we are discussing either the skewed data or ordinal data. Skewed data is that when the data values, which is a quantitative variable, does not follow a normal distribution. In our scenario, we are discussing the dependent and paired sample test, which we have already discussed a same scenario when we were discussing about the paired samples t-test. These tests are applicable when we usually test before after effect. For example, observing the weight before the exercise and after the exercise of the same person. So what we are getting, we are getting the paired observation from a single person. For example, we want to observe the work performance of hospital employees during their duties in the day and night. So work performance is being checked in day and night of the same employee, and this work performance was observed using an ordinal scale, which is poor, fair, good, very good, and excellent. Testing the claim that employee performance on their day and night shift were same or not, we have to apply Wilcoxon Silent test because the outcome variable is an ordinal variable, and we have to check the we observe for same employee in day and night. So in our scenario, we are going to discuss the HSP data, and this time we are going to observe test the hypothesis that there was no significant difference between the mathematics and science scores of students. So this is the math and science score. We have to first seek what kind of variable we have. Since math and science score both are quantitative variables, so we will have to check the normality for both variable, uh, that is math and science score. To check the normality, we will follow the step like we will go to the analyze, then descriptive statistic, and the explore. In the explore, we will put both variable in the dependent list, and we will check in the plots. We will check the normality property test. We'll press continue, and we will press OK. When you press OK, the output file displays too many tables and the graph. We will have to seek the table test of normality. In the test of normality, we will seek the Shapiro-Wilk test, and this SIG column. This SIG column is nothing but the p-value. This p-value, if any one of the p-value is less than 0.05, we can proceed to the Wilcoxon silent test. Here, both p-values are less than 0.05, so we will have to go for the Wilcoxon silent test because the data values does not follow a normal distribution. To go for the Wilcoxon silent test on our example, first we have to formulate the null and alternative hypothesis. So we have the null hypothesis. Average mathematical science scores are not different, and alternative hypothesis, the average mathematical science score are different. Step number 2, alpha is equal to 0.05, which is nothing but the level of significance. Test we are going to do Wilcoxon silent test because the math and science score did not follow normal distribution. Rejection region is that reject null hypothesis p-value less than a alpha. The computation is going to be in the next slide. So we will have to go to the analyze the non-parametric legacy title and two related sample. In the two related just like t-test, we will transfer the mass and science score, which are our variable concern. We are going to apply Wilcoxon test. Press OK. When you press OK, so we will see the p-value. The p-value is in the second table, which is 0.106, which implies that we are failed to reject a null hypothesis, that, and we will say there was no significant difference in the mathematical and science scores of students.